ethanoic acid. So from the name itself, we can able to identify acid means it's a COOH group is there. So eth, so it contains the two carbon atoms. So CH3COOH. The other name for the ethanoic acid is acetic acid. So the properties. So the again the ethanoic acid is the colorless liquid with a pungent smell and the sour taste. So it is easily soluble in the water, and a solution of the 5 to 8 percentage ethanoic acid in water, we call it as a vinegar. Okay, so the vinegar we are using in the day-to-day life as a preservative in pickles and all, we will be using food and all, because if the in the food, mainly the pickles, it contains the oil, so we have to preserve it for the long duration. So if the oil is there, it will easily oxidize and it becomes a rancid. So to avoid that, we have to add the vinegar. It is acting as a preservative. It will avoid the oxidation of the oils present in the pickle. So esterification reaction, one of the important reaction. So ester. So we are forming the ester from the alcohol and the acid. So ethanoic acid reacts with the ethanol to form the ester. The name of the ester, we call it as ethyl ethanoate in the presence of the concentrated sulfuric acid. So ethanoic acid, the formula is there are two carbon atoms, we have to write it. Acid is COOH, CH3, we have to write it because we have to make the two carbon atoms, it's ethanoic acid. Plus ethanol. So ethanol, the oil indicates the OH, the alcohol group, and there are two carbon atoms, so C2H5OH, ethanol. So again, we are using the concentrated sulfuric acid. So we know that we have to remove the water molecule from these two reactants. Okay. So how to remove the water molecule is, so we have to take the OH from the carboxylic acid and H from the alcohol. So we will be getting the H2O here. See, so now we have to write like this way. So CH3CO is there, CH3CO. We have to write CH3CO. In organic chemistry, we have to write where the bond is breaking, there only we have to form the bond. So in this case, CH3, here the bond is breaking and here the bond is breaking. So we should not write CH3CO, C2H5O. That is a wrong way. So the bond is breaking over here. That has to be combined with where the bond is breaking over here in the next one. So CH3CO, we have to write like this, CH3CO. Then here the hydrogen only we have removed. The oxygen is there. So we have to write the oxygen, then uh, the backwards we have to write it oxygen, then C2H5, oxygen, then C2H5. So plus water. So the name of the ester is ethyl ethanoate. So when the acid and the alcohols, when we are combining in the presence of the concentrated sulfuric acid, so we will be getting the ester. It's very sweet smelling, pleasant liquid. This reaction we call it as esterification reaction, one of the important reaction. The next one is the saponification reaction. So what is the saponification? So whenever the ester, it is reacts with the sodium hydroxide, so we will be getting the sodium salt of the carboxylic acid. So that we call it as a saponification reactions. For example, so the ethyl ethanoate. So the same formula, CH3CO C2H5, CH3CO C2H5, ethyl ethanoate. We are treating it with the sodium hydroxide. Okay. So now what will happen over here is, so the bond will break over here. Um, okay. So now here we have to break a bond. So the ONA, we have to attach it with the CO group. So it forms the CH3COONA, and C2H5OH like this. So we are getting the ethanol as a one of the product. So actually in the place of the Na, if you are having the hydrogen, then that we call it as a acid. COOH is the acid. But here the sodium is there. So what we have to say is sodium acetate or sodium ethanoate, we can say. Both are same only. So acetate is the actually the common name, or sodium ethanoate also we can say. So again I'm saying, so CH3 over C2H5, the bond will be breaking in between the two oxygen atom. So the ONA will be attached with this CO group and it forms the carboxylic acid, sodium salt of the carboxylic acid, and the ethanol will be forming. The alcohol is the another product. Next, the ethanoic acid can able to react with the base. Yes. So this is the neutralization reaction. We call it as because when the acid reacts with the bases, usually we will be getting the salt and the water. So CH3COOH reacts with the NaOH. So we will be getting, so again the water will be formed. So here the hydrogen and this OH will be removed. So CH, so this hydrogen and this. So in the place of the hydrogen, the Na we have to substitute CH3COONe plus water. So in the saponification reaction, we will be getting the ethanol as the product. In the neutralization reaction, we are getting the H2O. But in both of the reactions, we are having the same product, sodium acetate or sodium ethanoate. So the next one reaction is ethanoic acid reacts with the carbonates and the hydrogen carbonates to form the salt, water and the carbon dioxide. So whenever we are treating the carbonates, so immediately we will be getting the carbon dioxide is one of the product. So carbonates. So if it is either the carbonates or hydrogen carbonate. So both the carbonates we will be getting the carbonates as one of the product. So CH3COOH acid, when we are treating it with the Na2CO3, so one of the carbon dioxide. So here the CO3 is there, right? So the CO2 will be removed, and in the place of the hydrogen we are substituting the Na. So CH3COONa plus water we are writing. Okay, how to balance the equation is, here there are two sodium atoms are present. So but here only one hydrogen is present. So that's why we are writing 2 over here to balance the to balance the sodium atom. So CH3COONa, so 2 here also the 2 plus H2O, because the one molecule of the acid will give you the one hydrogen. So here the two molecules are there, right? So it will give the two hydrogen atom and one more oxygen is left out over here, because out of CO3 we are getting a CO2 only. So one oxygen is left, that oxygen will combine with the H2 and forms the water. So again the product is sodium acetate plus water plus carbon dioxide. So the difference between the NaOH and the Na2CO3 is, in the NaOH we will be getting only the water molecule, but in the carbonate reaction, apart from the water, we are having one more gas, CO2 we will be getting. So in this reaction we will be getting the bubbles. So the bubbles indicates that the carbon dioxide gas is released from the reaction. CH3COOH plus NaHCO3. So this we call it as sodium hydrogen carbonate. So this is sodium only, the atoms are there. Here only one sodium atom we have to write it, plus hydrogen. So NaHCO3, sodium hydrogen carbonate. So from the carbonate we will be getting the CO2 gas, and in the place of the hydrogen we are substituting the Na. So CH3COONa, and here one hydrogen atom is there, and here one hydrogen atom, and here one oxygen, that forms the water. So we need not balance the equation over here. Everything is balanced. But previous case only, so we have to balance the equation by 2.